In this vid, we're going to discuss graphing circles, okay? The reason why is because it's kind of a unique deal in the sense that there's nothing really else like a circle due to the fact that, it's kind of a perfectly round shape, or at least all the points on the circle. I say if this is a circle. Whoa, that's not really a circle. That's like a dented circle. But all the points on the outside are equidistant from some center, okay? So we're going to talk about this algebraically today, but let's start by talking about how necessarily we might identify the equation of a circle. Okay, so in the most pure sense, we say the equation of a circle is actually kind of unique looking. We say is x squared plus y squared equals r squared, and I think you can probably already gather a little bit about what I mean by r. But we say r represents the radius. Now I want to point one thing out here. R is the radius. Okay, r is the radius. This right here, however, is r squared. So for example, let's say r squared, this value were actually 25. One might necessarily infer that the radius then was 5 because r is the square root of r squared, okay? So if we look at this, what I want to do is I want to kind of expand on this. What we're gonna do is we're gonna list the standard form, okay? So the standard form of the equation of the circle, okay? Of a circular EQ. Okay, that's supposed to be a circle. We say it looks like this. In general, x minus h squared plus y minus k, this quantity squared, equals r squared. Now you're going to notice I introduced a few new things here, and these things aren't that new if you've been watching the videos, but we say h and k, actually what these do is they represent horizontal and vertical translation. But what we say is, in terms of a circle, we say the standard form of the equation of a circle, we say, okay, a circle with radius r, okay, and center or focus, okay, so the middle of the circle is called a focus, at hk is given by this equation. So what I want you to notice is this. The two things we'd be immediately after when we see the equation of a circle and standard form of equation of a circle are a few things here. We say the center of the circle, and also the radius. Okay, so the radius, and we said the radius is simply r. Okay, so the best thing to do here is we kind of look at an example. But what if we came up with the equation of a circle? We said, okay, so it's that x minus 1 squared plus y plus 2 squared is equal to 4. Okay, that'll be easy to deal with. A few things I want to point out right off the bat, and those things are these. We say this right here, this value right here that's hanging out with our x inside this parenthetical quantity is our h value. And this value right here is our k value. And this is important because what this does is necessarily tells us where the center or the focus of the circle is. So the first thing I want to do is when we graph a circle, we say, let's go ahead and list the focus of the circle. Now, the hard part about this, I have an okay time explaining it, but a hard time getting people to understand it, is the fact that h and k, when they're in parenthetical quantities like this, tend to be backwards of what you might think. And what I'm getting at is this. We say the focus here, if we say h is this value here and k is this value here, what I'm going to tell you actually is this. H is a positive one, okay, positive one, and k is a negative 2, contrary to what you're seeing right here, okay? And the reason why this occurs is because if we go back and look at the standard form of an equation of a circle, we notice that these involve differences. And whenever you're dealing with a difference, it kind of makes things operate a little bit backwards. And another way to look at this is this. We say, okay, so this would be x minus, we look at it another way. We say x minus, and we'll put that 1 in parentheses here. It was x minus a positive 1, okay? So this h here is actually a positive 1. And we say, okay, so in this instance, we said we had y plus 2, but in the original equation, or the standard form of the equation of a circle, involves a minus here. So what if I wanted a minus here? Well, let's go ahead and put it. We say y minus, okay? But the question has to be this. So what could I subtract from this y in order to flip this back to a positive 2 like they've listed here? And we say, well, then I must have selected a negative 2, okay? So now we end up with this, and we say, okay, so now 4 squared. Now what I want to point out is this. This quantity right here represents r squared. So if that's the case, what I could necessarily do is rewrite this as 2 squared. And that's important because what we're saying really is this. R is the radius. In this case, r is 2, okay? R squared is 4, however, r is 2. So now we say, okay, so radius. We do have the radius of this circle. So we got the three things we were after. We say this is a radius of, a circle of radius 2 that has its center at +1, -2. And so to sketch this, you just got to kind of be careful with it. I don't have a circle tool on this, but we say, okay, so 1 over 1 down 2, and we'd have something that looks maybe like that. So here's our center. Okay, we say 1, -2. And we also know this, it had a radius of 2. So if that's the case, I'll go ahead and switch colors on us here, but we say, okay, radius of 2 means, I proceed out 2 in all directions. So 2 this way, 2 this way, 2 this way, doink, doink, and then 2 the other way. But we'd say, here would necessarily be our circle. If you think about it, circles are kind of straightforward to draw in the sense that all we want to know are a focus and a radius. Okay, so let's give this another shot here, actually. And oops, I didn't want to grab that. I just wanted to do this. Let's go ahead and grab a different color here, but let's really kind of work on one more example. What if I came up with this equation here? We say x squared plus y minus 3 squared, and we'll call this one like, I don't know, 16. What I want you to notice all of a sudden here is this. This does appear to be the equation of a circle. You're going to see this, you look back up here, we say we've got an x squared summed with a y squared, and we have something over here that in this case happens to be a perfect square. Don't expect it always to be. But this looks like the equation of a circle. The thing that's odd about this here is that you're going to notice that, we're saying if this really is a standard form in general, you're going to notice that it's kind of missing an h quantity over here. So what I'll do from time to time is recommend that students rewrite it like this: x minus h squared plus y minus 3 squared equals 16. Or in other words, let's just do this. Actually, let's write x minus 0 squared. Okay. So let's go ahead and we want to graph this. A few simple things we want to know. First things first, where's the center? Where's the focus of the circle? We say the h value here, h which is always with respect to x. H is always hanging out with x. We say h is 0. In this case, we say k. Now recall that k is backwards. Okay, so if this says -3, what we really want is the +3. And we say, okay, so what's the radius? What's the radius of this circle? The radius of this circle, if this right here represents r squared, then r squared, that would necessarily imply r squared equals 16, which would imply also that r is 4. Okay, so we say radius of 4. So now sketching this, we say, okay, I've got a circle centered at 0, 3. It's a radius of 4. So, we could go down 4 from here. And say, from this, oh my goodness, maybe we go left 4, right 4, and up 4. Just be a little bit careful because I'm not a very good sketcher on this thing. But we say, and simply put, this is our circle right here.